Okay, guys, welcome to today's show. Before we begin, I have an announcement to make. My book has been translated to English and published. So now it's available at this link right here at books.drbirch.com. And the book is about network technology. It has been in store in Sweden for a couple of years and done very well. So my publisher agreed to translate it to English and help me with that. And now it's available all over the world, pretty much. And it's an ebook that you can buy online on this page. And the list price is going to be $26. But for the next couple of days, my subscribers will be able to buy it for $14. So this is a great way of supporting the channel, and it's a great way of learning how internet works and how to understand the different network protocols and stuff like that. It's a complete beginner's course, but also some advanced elements for people who already know some of this stuff. Alright, so books.drbirch.com. Let's begin with the regular episode. Hello everyone, welcome to today's class. So, today we're gonna continue on the very exciting project of building our own virtual machine in C. And this far we have been focusing much on the move instruction, and I don't really want to make a third episode about that. We still have work to do when it comes to move, like moving data, moving between registers and so forth, but not today. When we try out our different instructions, etc., we have this very ugly and difficult example program function. It's only temporary. We will remove it when we are done with the development, but it's very difficult to work with even in development. So I want to create a function which basically is what is called variable-arity function. So it will have a different number of arguments, and basically I just want to give all the instructions in a long list. So let's try developing that. And in order to be able to do that, we need to we need to have some kind of function which generates the bytes, the machine code of one single instruction. Then we can easily extend that. So let's see how best to do that. I think the easiest way would be to create. We have basically two ways of doing this. Either we can create, so we have like, let's say an I0 function, where I stands for instruction and 0 is the number of arguments. So let's say this will generate program pointer, and it will take an opcode as an argument. So we'll call this function by doing something like program p and then we'll just do p equal I0 halt, for example. So that's one way, and then we will have a second function which will be I1, and this will take an opcode. This will also be a pointer, by the way. This will take an opcode, and it will take one args argument. And similarly for the I2, we'll have opcode, args, and args. So for example, we could call it by doing I2, and then we want to move, let's see, what would be the arguments in this case? The first would be a 0, I suppose. I can't remember the ordering now, but something like this, I think. So this will be 8 bytes, and this will be 8 bytes. And together it will be the number 5 in a 16-bit sequence. So this is one way. The completely other way, or not completely other way, but the other way that I'm considering is we just create an I function. And the I function takes an instruction. And if you remember, instruction is a structure which has an opcode and 2 possible arguments. So basically the same as these functions. It's cleaner to just have one function. This will be easier to code though. And I'm not really sure how it would deal with different arguments. Well, maybe we could do something like, if we use this I function, we could create one function per instruction, but I'm not sure if that's good. Let's see, what am I thinking here? It would return an instruction. So let's say I move, and then we will have args, and this will return an instruction that we can put inside of the I function to get the raw bytes, and then we can create something like program example program, which takes a variable number of arguments. I'm not sure how I would do this actually. I would like to ask you guys, but I do want to code it right away, so that's a little bit problematic. But I think I'm leaning towards this. And maybe we don't need to have these. Let's see what's necessary and not. Let's start coding and see where we end up. That's usually a good way to deal with it. Right. So let's see. Where do we start? Where do we start? First of all, we need to have some function which takes an instruction and returns the raw bytes. Right. And I think we need to allocate it on the heap. Let's see how it goes. So this would be the I function then, which will take an instruction, inster, no, inster is tough to write. Let's do this. And what do we need? We need a program, P, and we need a size. So let's do an int 8 size, and the size will be equal to our map function given the instructions opcode. If I remember correctly, let's see the map function. Yes, it takes an opcode, and the instruction is this one. So opcode O. So just IO. So this is the size. So now we know the size and we can allocate for it. So P will be equal to the program casted malloc of size. And we can assert that we do have P. Okay, so now we have somewhere around 1, 2, 3 bytes. So now we want to copy the byte value of the instruction. Or how does this look, by the way? An instruction has an opcode and it has a 0 arguments list. Right. So we should just be able to copy the whole thing, I guess. Let's try. So we copy to P and we take the address of I and we want size bytes. Then we return P. This should work in theory. So now we can take an instruction and turn it into a byte stream, so to speak. Let's also make a signature. this will be program I, and we give it an instruction. Okay. So how can we compose these into a long list of these program instructions? And we need to put it inside of the virtual machine's memory. First of all, we need to deal with the variable-arity thing, because we want the signature sample program, which takes virtual machine and then just dot dot. Is it 3 dots? I can never remember. I don't use this very often. I don't think anyone does. And I'm not going to be using the stuff that is included in the C standard library. I don't really like those macros. Fortunately, I have my own. I created a little project which is called x86 args quite a while ago. So let's include x86 args.h, and I don't remember if I have it on this machine. I need to check. Yes, it's there. So I will put this on the repo, but this is it. This is the whole program. So basically, we have this signature. We have the args function, which takes an integer pointer and returns an integer pointer. So let's see. That's right. This specific thing is only dealing with it's only dealing with integers. But I think since we'll be using pointers, it will basically be the same thing, right? So let's see. We have the args, and we take an argument to that. It will create a temporary variable, and it will set this argument to that. And how are we supposed to access the other ones? Can't really remember how I did this. Maybe if I remember which project I used this in, what could it have been? Maybe the print F I wrote. Let's Yeah, let's connect to Code Planet. Let's go into code, printf, no. Let me search for it. Okay, this is a couple of things. But I don't think it's the stuff I'm looking for. Alright, so if it's not on Code Planet, it's probably here somewhere. Maybe in the repo. Let's go into the repo, printf. Nope. Printf. Where did I put that code? Never mind. I'll figure it out. I will figure it out. So let's see, arg equals x, which is basically the base pointer plus 8. The arg is the first argument. Unsigned int. Well, easiest way is to try it out, right? So let's do something like this. And we will have an unsigned int I. No, we can't name it I. Maybe it wasn't too clever to name the function I. Never mind. Let's call this N. And I need a program P. Let's wait with that. Let's create an instruction. Yeah, let's create an instruction P. And then we will run args on this N thing. So that should basically be the address of the first argument. So we should be able to do something like P equals the instruction and I guess. print out hexadecimal value of P, something like this, and I will return a program casting 0, like so. And let's just let's see. After this, we have a virtual machine. So now let's call sample program, and let's rename this other ones now. This old one should be number 2 instead. And let's just comment it out inside of the function declaration part of the code. And then we'll try to do example program VM, and then here we need an instruction. So we can do and inside of here we should have an instruction. So let's say instr exit 0. Let's create an instruction instr, which should be equal to the opcode is move, and then what do we do? Can we do this perhaps? So A0 is 0 and A1 is 5. If this is correct, C, then we should have an instruction created this way. We pass it to this I function, turn it into bytes. Right. Turn it into bytes. Yeah, this I returns a program. So we'll give a program to this argument. Let's say this. So this shouldn't be an instruction. This should be a program. I'm not sure about this, but let's see what happens. One need to try new things sometimes too, right? Oh, the whole world of errors are raining down on us. Let's see, passing argument 2 of copy from incompatible pointer type. This is probably just a casting thing. 290. So let's see, 290. We are here, and this should be update like so. Let's try again. Okay, that's better. Non-static initialization of a flexible array member. It's complaining about A1, but not A0. That's a little bit interesting. But basically this says that this won't work. But that's just a minor inconvenience. So instead we'll do instruction instr as a pointer. Inst will be equal to, and let's malloc 3 bytes. We will set instruction opcode equal to move, just like before. We'll set instruction A0 to 0, and we'll set A1 to 5. So this should be equivalent to this, I think. Maybe we can do a 0 as well, just for the sake of it. So we want to 0 the instruction 3 bytes. Right, let's see what happens. Instruction undeclared. That's right. So we'll have an instruction star inst. Incompatible type. Instruction. Expected instruction, but got an instruction star. Okay. So let's see. Let's just modify our I function, making this a pointer, and then it will be I arrow O, and that's the only thing we need to change. This we need to change as well. Right. Conflicting types. Right, we need to update our H file. And the little star right there. Okay, it compiled. So let's see. If this works, we should get an 8 from this function. Get a 0. Why do we get a 0? Let's see. We are printing the value of P. And P is pointing to N like this. but we want to grab this address, and that's what we want to point to. Can we do this perhaps? I'm not sure. The syntax is a little bit weird sometimes. It compiled, but it crashes instead. Bummer. So let's see, what is the value of n? N should be, let's not guess. Let's print the value. So let's do 0x percent 8x So now it should print this. Let's flash as well. Now it should print this and then crash. Alright, it looks like an address on the stack. So why can't we dereference that? Let me just check what this is trying to do. And it's always difficult to paste into GDB. There we go. I'm just setting up some macro to make it a little bit easier to see what's going on. So let's see. We're trying to move into EX the value of EX. Okay. That's a little bit troublesome. So we have all zeros at this position on the stack. That's a little bit weird. I think. Okay, so let's see. N contains the address to the stack, but that position is 0, so maybe we are sending the wrong thing to this function. Let's see. It would be interesting to see what this I actually returns. And that is a program, right? So let's see. We can set prog equal to I inster, and then we can try to print. If you wonder what this HHX means, if we just do X, then it's a 32-bit value. HX is a 16-bit and HHX is a 8-bit. And in this case, I want to print a single byte. Or 3 of them actually. But let's start with prog. And then we'll have, let's do it like this. Yeah. So what does this mean? Prog will be equal to what this returns. Oops. And this should be 3 bytes. So we print the first byte, what this prog is currently pointing to. Then we increase this pointer, so it points to the next memory address. So when we run this, we will print the next one, and then we increase again. And the third time, we will simply print the value. So basically, this is one way of doing this. I could just do prog plus 1, prog plus 2, but this works as well. I think this is a little bit more optimized, perhaps. I'm not sure. Okay, so we have 080000. Almost what we want. But not quite. We don't get the argument. This will return 3, I think. Let's check the map function. Yes, 3. And we allocate for that, and we copy 3 bytes from P to P from I. Maybe it's something weird with how the memory is laid out with these enums and stuff. I remember I had trouble with that before. Perhaps we should do 2 copy steps instead. So first we copy 1 byte, and that is just, well, we can basically have this. But then we want the arguments. which should be size -1, since we have already done one. And instead of just doing I, we should do IA, the argument. Let's see if we get a different result. We did, but now everything is 0 instead. Why? We copy over itself. That's not smart. Let's do the same way as we did with the print before. Okay. So into P, we copy 1 byte from I, and then to the, okay, we can't really increase this because we are returning it, so we need to have it pointing to the first position. Let's do this instead. Eight, 0, 0. A0 is 0. A1 should be 5. We allocate 3 bytes. Wait a minute. This is a 16-bit thing, right? Which means there's not really room, and we are doing this wrong. We should only give 1 argument, and this should be the 5. Okay, so this is what I was looking for. I guess. So how do we get the rest to work then? Now we know we are sending the right thing. So we can basically remove this thing. Let's watch it crash again. And we're pointing towards this. And if we go back to let's see. Let's do this. Still 0. Args n. What happens if we don't use this integer thing and we go directly at P? that work? Maybe we need to cast it. But how? Can we just do something like this, perhaps? No. I think we need to alter our x86 args a little bit to make it work for program pointers instead of integers. Yeah. So let's just do something like this. Let's copy this whole thing. And we can create a new file. x86 args.h. Instead of unsigned int, we can make this. Can we do something like this? This. I'm not sure. Let's change. So we are using our own thing here. All right. I don't need to cast it any longer. Compiled, and we still get a 0. Let me just try something. Okay, it compiled. segmentation fault. What if we were to do something like this? But I don't really know if it will do much difference. No, we still get that 0. Let me check one thing before we abandon this way of doing it. As in code as in Variatic GP. Why doesn't it hit my breakpoint in the function? That's pretty weird. It's like it's not even running this function. Is it optimizing it away? Because it thinks that it knows what the value is. Let's try removing this. Oh, 0. Okay, now we hit the breakpoint. And now we get the value. Okay, so the compiler was fooling us. Since we are using pretty advanced stuff, basically we are talking directly to the CPU registers to figure out the argument list. And the compiler did not understand that that was what we were doing. The compiler thought it knew what the value should be, and that it's a 0, but it's not a 0. So when we turned off optimizations for the compiler, then it let us run our function and actually produce a value. So now we can probably get what we want. If we were to do something like this, I guess. B0. That's probably the beginning of the address. What if we were to alter this a little bit? If we were to do a double star, and then we do double star here, and then we want one with only one star, and we set P2 equal to dereferenced P, and then we dereference P2. And we're back into 0. At least it doesn't crash, right? So what do we have inside of our EBP? This is what we get. That's why we got the BF before. But what is inside of this address? Zero. Right, I'm looking at the wrong thing. I should be looking at this plus 8. Okay, Okay, so here is the actual data. So why do we not get different results? Oh, fuck this. We can probably figure it out if we put a lot of time and effort, but it's not really worth it. Let's do the standard C implementation of this for now anyway. It's only an example function anyway. So let's see if I remember how to do that. Logs. What am I searching for? What's it called? VARgs or something. Can't really remember. Uses allocator args. Argz. Okay, that's not the right one. sorry. Okay, so let's see. Variable-arity function C. 1,000,000 pop-ups. Let's see, VAR. Okay, so it's one of those annoying underscores that are making trouble for us. VARgs. Arg. There it is. Okay, so first we do a VA start. stdarg.h. Weird that I didn't find that one. It's inside of the C++. That's pretty weird. Is it the right one? Perhaps they are exactly the same macros for C and C++, so they have put them inside of the same. Whatever. Let's see. The arg. So first of all, we need some kind of VA list. So let's do that. VA list. Then what? We need to call VA start, and we give it one of our arguments. So VA start, and we give it app. Maybe it wants the reference. And then we give it VM, I guess. And then we have the VA-arg thing, which will take the structure and then the type of variable that we want. Okay. So I guess it should be something like P is equal to VA-arg is acting, and well, it's a program star. Is that what it wants? Let's remove this P2. This should just be like this. And would you reference it like this? Remove that and that. Do we need to clear it somehow? VA end. So something like this, I guess. And we need to try to include stdr.h. Okay, so we need to give it the actual value then, I suppose. Like so. Hit compile. And it works. Okay, sometimes I guess it's not disallowed to take the easy route. So basically we can call this varg as many times as we want, and then we will get different values basically. And we want to use those to produce a long string of bytes. And we don't know the size of that thing. So basically this program P, this is what we're going to return, and we need to have this inside of our virtual machine's memory, which means we will not do it like this at this point. We will set P equal to the virtual machine's memory, M. And then we'll just put everything there, one thing at a time. And if it overflows, it overflows. That's up to the user, basically. So let's see, how do we know when we don't have any arguments? When we have gone through every argument, does it return 0 or what does it do? My page must tell us. If there is no next argument, blah, 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 random errors will occur. This is really a great function, right? Well, at this point, it's not really our problem. We will create a function which does what it does based on the input. And if the user sends the wrong thing, then the user is to blame. We don't need any kind of error checking here. So basically we will just have a while loop to loop until the opcode is equal to halt. So we will create an opcode. And maybe we should have something like this, where we set the instruction equal to vararg program star. And the opcode should be equal to the opcode of whatever this is pointing to. And this is only so we can look for the halt thing. Then we want to copy whatever we have here. But how do we know how much to copy? It can be a variable length. So we need to use the opcode to figure out the size. So let's have an int size, and we'll set the size equal to map opcode. Then we want to copy into P, our memory. Then we want to copy whatever we have in this argument. So basically we'll just give the instr here. And we want to copy this size. And then we need to increase P by that size. And then we do this while check. And that's basically it. So we can just return the P. I guess this will work. I think so. How can we try this? So let's see, here we have an instruction, move. Create a virtual machine, we run the example program. Let's try creating an instr2. here we'll just malloc 1. Then we will 0, 1. Then we will set the instr2 opcode to halt, and there's no arguments. We set the program to example program, and we send instr2 as well. And let's print the value of the AX register. And quit. Here. Okay, we do that already. So if this works, we should have a file with the EX, I think. It compiled directly. Huh, interesting. It's a VM segmentation fault. I don't think I even remember what that is. rseg, what can cause that? Seg fault. Okay, so this is one occasion. Where are we? Execute instruction. So basically it's failing to get the size. Okay. What else can it be? If people, oh, maybe we didn't alter the break, so we are trying to execute instructions. Right, we're trying to execute instructions on the stack, and that's a valid seg fault. Okie dokes, so let's increase the break line inside our example program. So every time we increase P, we should also increase the VM break plus equal size. I think it's called VMB. Let us double check. Yes. And we have 5. Ladies and gentlemen, it works. Oh, beautiful. This will make it a lot easier to test different instructions and so forth. I don't like, however, that we need to allocate on the heap for everything. I don't like that much at all, actually. How can we go around that and still be able to pass arguments? Well, we can still allocate it temporarily on the heap. I just don't want to do it manually each time. So can we give a different input to the eye, perhaps? Because it wants an instruction. Maybe we need to do my first solution after all with different functions. So we will do something like program, let's say I1, and this will take not an instruction, but it will take an opcode directly, and it will take one argument directly as well. How did we define args? So in this case, we want to have an instruction I, and we also need a size. And the size we take from the map function and the opcode. Then we will allocate for the instruction. We will zero it out. We will copy, let's see, we will set the, how do we do this? We'll set the opcode inside of this to our opcode, and same with the first argument. And then we will return I. Let's also assert that we have an I. Okay, this isn't the most prettiest code, but it works, I think. So now we do the other one. This is I2, and we it'll have a second argument, args a2. And the only difference is we will set the a1 to a2. And we also need one without any arguments. This will be I0 and no arguments. We will allocate, we can do that in the same way, but we'll remove this. So I0, I1, and I2. Like so. Let's create some ugly signatures to these ugly functions. So this will be instruction I0, which will take an opcode. And then we'll have 1, 2, and this will also have an args, and this will have an args. So how do we use this? Let's clear out this old one, by the way. And we don't need all of these instructions. Let's remove all this. And here we can do something like okay, so now we can call the I, and we can pass the I1, and this will be a move to the AX of a 4, let's say. Then let's set, let's see. Then let's set the equal flag. And then we'll halt. Will this work? Oops. Conflicting types. Program I0. It should not be a program. It should only be an instruction. The same for all of these different ones. Let's see what happens. Okay. Okay, it's compiled. And it works. AX is 4, E flags is set. Beautiful. And that's all for today, friends. If you like this episode, please like and subscribe, and go buy my book. Thanks for today. Take care.